Okay, now, so the meeting is being recorded. So first thing first, before we integrate, let us first see what does it mean by double integral, triple integral, and so on. So let me start with something that you guys are familiar with. A normal integral, nothing much, a simple integral. Usually, when we integrate something, you will see that we would have a function fx, of course, and you will have an interval from a until b. You would have this, an interval. That is how you have a function fx, and underneath your function there's an interval. When you integrate, you are getting the area under the graph. It's not a new concept, you know this. But when we extend to, let's say, double integral, why do we call it double integral? Because now, simply, there are two integral signs. So if you have a function which has x and y inside it, for example, 3x plus 2y, or x times y cubed, for example. So this kind of function, when it contains x and y at the same time, if you actually use some kind of software to plot it, it's going to be a three-dimensional object. Of course, you can't draw it on a piece of paper because it's a 3D object, but if you use some kind of software, you would see it's a three-dimensional object. So imagine you have a three-dimensional object. When you look underneath the three-dimensional object, we are no longer talking about intervals. No, we are talking about a whole region underneath this. Makes sense, right? When you have a curve, one variable, underneath it, you have an interval. But when you have a three-dimensional object, you look underneath, there's a surface. That's how it works, right? So that is to say, if you want to integrate a three-dimensional object, all right, so okay, it's a 3D object. Underneath is there must be a surface. So what you are getting, when you look underneath the three-dimensional object, you're getting a whole volume. So that's why one way to interpret double integral is that double integral gives you volume. Now this, you can still imagine it. And by the way, if suddenly my Microsoft is muted, please let me know, right? Because if you sense that I'm not talking for some time, something fishy is going on. So just let me know. Anyways, for triple integral, I can't even tell you what it means by using a diagram, because imagine when you have three variables in a function, when you try to plot it, it's actually a four-dimensional object. I can't even draw a four-dimensional object. Imagine there's a four-dimensional object. We can't even see because the human eye can only see up to 3 dimensions. But imagine there's a four-dimensional object, and when you look underneath the four-dimensional object, down here, there would be a 3D object. Okay, so just like just now, you have a 3D object, underneath it, there's a two-dimensional region. If you have a four-dimensional object, underneath this, there's a three-dimensional region. But it's very hard to justify by using diagram. But mathematically speaking, not drawing diagrams or anything, mathematically speaking, you can even integrate 1, 2, 3, 4, 5 times. Mathematically, there's no problem. But if you want to visualize it, we stop when we come to double integral. Because apart from that, it's kind of hard to imagine what it means. Okay, so that's the meaning of what is a double integral, triple integral, and unfortunately, above that, can't really imagine what's going on. So now I'm going to teach you how do you actually integrate mathematically when you have two integrals or more with you. This example might be a bit sudden. Okay, let me start with another cooked up example here. Imagine you have a function. Let me quickly cook up an example. Let's say, okay, just xy. Let's say just xy. And I want you to integrate this function xy with respect to, let's say, dx. Okay, take this. Now you have x and y inside it, but I ask you to integrate with respect to dx only. So if you are integrating with respect to x, this is the important part, keep your y as a constant, right? That's the idea. If you integrate with respect to y, then your x is a constant. Okay, all the other variables apart from the one that you are integrating right now is just a constant. So let me show you how this works. Okay, so if I'm integrating with respect to x, my y is a constant. Imagine if you're integrating a constant times x. How would you integrate this? It would simply become no, you would not have to note it down, because after the class ends, I will give you everything that I just scribbled as a picture format, so you can always refer to it whenever you want to. Okay, so you don't have to note it down. Just try to follow along. So if you are integrating 3x, what you would get is simply 3x squared over 2, basic integration plus c, of course. So similarly, if this is how you treat a constant, then treat the y as the same way. Y is a constant. So what would you get if you integrate this? You will be getting x squared times y over 2. You treat the y as though you would treat any other numbers, because y is just a constant. Okay, all right. So this was a random cooked up example. Let me do something that is more complete. Okay, for a while, let me just delete this. Okay, so anyways, back to a more solid example here. Now, as I told you, this part you have two integrals. You have one integral sign and another. So obviously you need a region down here, and this is actually the region. Let me just put R as for region. It's just a very convenient way in mathematics to write a rectangular region or maybe a square region in this form. This simply means the first interval is simply the interval for x. The second interval is simply the interval for y. Sometimes you even have another bracket here that is for z, and so on. Okay, so it's just a fancy way, a mathematical way of writing the limits for x and limits for y. Anyways, now getting to the problem, you have two integrals. Okay, let me just write two integrals, and it's 6x y squared. All right, now let us write dx and dy. Why x and y? Because they are one coordinate for x and another coordinate for y. There's no z or anything. Alright, so let me just put x and y here. So my x limit is from 2 to 4 according to the question. So let me just write 2 and 4. The y limit is from 1 until 2. So at least now I got the question right. So now we want to solve it. How do you solve a double integral? The key point is always start from the inner part and then you go to the outer part. For a while, guys. Yeah.
Supposedly at 6, right?
Oh, is someone coming in now?
Supposedly after this there's someone.
At 4 o'clock.
3:15.
Okay, I'll see. Okay, right. Thank you. Okay, just for a moment, guys. Let me just pause. I need to move on to another room. Stay here, right? Be back. Alright, I'm back. So sorry for the inconvenience. I actually went to the wrong room. I was assigned a different room. Anyways, can you hear me now? Is everything clear? Just
Yes,
someone
sir.
say.
Yes, sir.
Okay, nice. So let's get back to where we were just now. Alright, so we were integrating this, and what I was saying just now. Alright, so now always remember that when we're doing double integrals, you start from the inner part and you go outside. Alright, so the inner part means between the two integrals, choose the one that is inside. Right, means that from the integral of 4 to until dx. So that is the inner part. So if you solve this integral, currently I'm integrating with respect to x, the inner part, so my y is a constant. So what do I get? If I integrate this, I would be getting 6x squared y squared over 2. That is what I would get. Because you're integrating x, all the other things are just constant. Okay, and the limits are from 2 until 4. So let me just write it here. And everything else remains, mean that the dy here still remain a dy. The outer integral still remains here as integrate from 1 to 2. Only the inner part is now solved. Okay, so this would be, can be easily simplified, alright? So 6 and 2, you just cancel it, it becomes 3x squared y squared from 2 to 4 dy. Right, so let me just check. I did do the question here before class. Just want to double check, make sure I'm not wrong. Okay, so now the usual method, you put in your 4 inside x. Remember to put it inside x because you just integrated with respect to x. Don't put it inside y. So if you do that, right, if you put in 4 into the x, 2 into the x, eventually what you would get is 36y squared dy. So can you see we just reduced it from a double integral into a single integral because we are done with the inner part. This part is not even something new. You know how to integrate this, right? So it simply becomes 36 and then y cubed over 3 basic integration, limit from 1 until 2. And I computed it just now. I got the answer is 84. Okay, so you can try it out later on. Okay, but the idea is this: solve the inner integral first and then the outer integral. Now, one thing that I took for granted just now, I didn't explain it to you why, was the fact that suddenly I choose dx and then dy. Why can't it be, just asking, why can't it be integral of 6xy squared dy first and then dx? So my y limit is from 1 to 2 and my x limit is from 2 to 4. Why can't I choose this? Is it because x comes first and then y in the alphabetical order? The answer is no. Okay, what is it? Y is always constant. No. If you're integrating with respect to x, then your y is a constant. Here, at one point, when I was integrating with respect to y, then my y is no longer a constant. It's a variable, a normal case. Right? So the variable that you're not integrating at the moment, that is what becomes a constant. Okay. Anyways, so y is not always a constant. The reason why I didn't choose this is simply out of my preference. That's it. No other reason. I just felt like I wanted to do dx first and then dy. If I did this version, believe me, you would get the answer 84 as well. No problem at all. Okay? Because no matter what you put, y first or x first, as long as you get the limits correct, the rectangle remains the same. Your x is from 2 to 4, your y is from 1 to 2. It's the same rectangle underneath the function. So no problem. For this example, if any of you want to purposely choose y first and then x, go ahead. You will get the same answer. Okay? So no problem with that. You can try it out later on. Let me delete this again. Okay. Now, so that was for a warm-up, a double integral. Okay? I would say it's kind of easy because both of the limits are numbers, 2 to 4, 1 to 2, everything was numbers. Sometimes, just saying, sometimes you might get something like this. Again, it's a double integral. Okay. Again, it's a double integral. However, you can see that the y is nice from 1 to 2. Number, fine. But the x is from y until y cube. Those are not numbers. So now, I just taught you that if you have a double integral, in this case ex or y, I told you that you can either choose dx dy or you can choose dy dx. I told you it's up to you. But in this case, imagine if you do dx. Okay, imagine if you do dy over dy and then dx. If you choose dy first, okay, then your limits are 1 to 2. Your y limit is from 1 to 2. If you choose dx afterwards, right, your x limits are y until y cube. So you can imagine in your mind, when you first integrate, you put in the y value to be 2 and 1. And then finally, when you integrate, you put the x values to be y cube and y. So your final answer here will contain some y here and there. It's not a number. You are not getting a value. So this is problematic. We want a number to be the final answer, not some kind of variable. However, if, okay, just saying, if you choose to integrate ex over y with respect to dx first and then dy, so you put your x limits to be y and y cube, your y limits to be 1 and 2. If you do the other way around, imagine you integrate something and then you put y cube and y. The final integration you put in 2 and 1. So no more variables in it. The final answer will be a number. Now this is what we want. We want the final answer to be a number. So the lesson here that I wanted to show you is that if you see that one of the limits are not nice in the sense that they contain variables, use that as your inner integral. Keep the numbers for the later part, for the outer integral, so that your very final answer is a number. Okay, so that's the lesson here, but of course I'm going to show you the full working solution to this. Okay. So what we have agreed for the moment is that we want to agree that we put the x first. So e to the power of x over y. Let me zoom in a bit. Okay, so ex over y, and I want to put dx first. I want to put in the variable one first. So x is from y until y cube. My y is from 1 until 2. Okay, all right, so let's do this. First thing first, you are integrating with respect to x. So your y is just a constant. So integrating this is like as though you are integrating e to the power of x over 3. Right? Your y is like a 3, it's just a constant. So if you do that, okay, all the outer part remains. The inner part, if I integrate this, is going to be e over x over y over 1 over y. The same thing that I would get if I integrate x over 3, right? Treating y as a constant. So the limit is from y until y cube. Remember, the y and y cube is what you put into your x, not your y. Okay, because currently you're integrating with respect to x. Anyway, everything else remains the same. Dy becomes dy, outer integral becomes outer integral. Okay, so at this point, you can actually simplify. Let me just write the simplified form. Dividing by 1 over y is equal to multiplying by y. So this is a bit more friendly to see. So you have y cubed, and then you have dy. So if you put your y cube into the x minus, and then you put your y into your x, what you will be getting is the integrate from 1 to 2. I did it just now. I got a, let me see, y e to the power of y squared minus y e. So this is what I get. So now the problem is a bit simple because it's no longer a double integral, but it is a single integral. So this Alright, this integration, I hope you still remember all your basic integration knowledge like integration by part, integration by substitution, trigonometric substitution. I know it's a headache, but you need to know that because we won't be covering it again and again in this topic. Okay, we are focusing completely on the double and triple part. The basic integration, my handwriting is nice. My goodness, I don't even feel it is nice. I feel kind of awkward writing here actually. Anyway, so where I was, even in fact, for this part itself, you see the integration from 1 to 2 of y square. Let me just break it down. Okay, it's not necessary, but let me just break it down because I want to show you that the left hand side is a bit hard to do, slightly harder. For this part, I actually have to let u to be y square so that if I do this, then you know that du over dy is equal to 2y, or in other words, 1 over 2 du is equal to 2 dy. Now why all this mess? Because I want to substitute the power y square here to be u, and the y dy, oh, sorry, there's supposed to be a dy here. The y dy, I want to change it to, wait a second, what am I doing? Sorry. Yes. I just got a compliment that my handwriting was nice and now I'm already making a mistake. Where were I? So if you shift the 2 there, here it becomes y dy. Anyway, so that's the whole point because otherwise it's impossible to integrate y e to the power of y square. So doing that by using the substitution, going to skip a bit of steps, okay, what you will be getting is eventually the integral of 1 to 4 of e to the power of u over 2. This is what you will be getting, right? This is by using the above substitution. So on this side, however, I don't need to do anything much because the basic integration itself, not that tough. It's just ye from 1 to 2. So solving this, again, not a big deal. If you solve it, you will finally get e to the power of 4 over 2 and minus 2e. Again, you can try it out. I'm not going to spend time doing this because these are basic integrals. Again, the lesson learned here, the new part today, is simply do the inner integral first, and when you want to choose, you want to put dx first or dy first, make your own judgment. See the limits that are kind of weird here. Let me write weird. The limits that are weird in the sense that they are not numbers, put it as the inner integral. The limit that are nice, put it as the outer integral so that your final answer is a number. In case, if any of you felt that the final answer was not a number, this is actually a number. E, if you put it in your calculator, is actually 2 point something, I don't remember. E, but it's a never ending decimal, so otherwise we just write E. This is a number. Okay, otherwise you wouldn't have gotten a number just now. Okay, so that was double integral, right? You know what's the nice part about triple integral is? There's no difference. It's the same thing as doing a double integral. It's only that now you have dx, dy, dz. So now you may ask me, I know that I have 3 integrals. I know there's a 8xyz here. But am I going to choose dx, dy, dz? Or am I going to choose dx, dz, dy, or any other combination that you can think of? Why not even dz, dy, dx? The answer is you can use whichever you want, because in this case all the limits are numbers anyways. So I want you guys to just take a piece of paper, to scribble. You don't need to send it to me, but try out this question here, and I will share with you the answers. So just try it out on a piece of paper. Okay, I give you some time, just try it out. And meanwhile, you have any questions, just ask me. And I would like you to share your final answer in the chat box, just the final answer. No need to show me the whole steps. Okay, so let's give a few minutes for that. Hey, sorry. if any of you are done, you can just type in your final answer that you got, right? And it's completely fine if you're wrong, it doesn't matter. And yes, the answer is 15. So the others, just make sure that you can get 15, right? If you don't get 15, you get completely something else, let me know. I can at least see what went wrong there. But 15 is the correct answer. Yeah, we have a bunch of 15s coming up in the chat box. Good. Nice, you guys are getting 15, which means you guys are quite fast learners then. You spend about what, 30 minutes and you already gotten how to do a triple integral. That's good. So 15, yes, so 15 is correct. Alright, so I'm kind of convinced that you guys can get that the answer is 15. So the others, just try it out. If you can't get 15, just let me know later when you have a small break. As for now, before we have a break, I just want to complete this example here. Alright, so this example is again computing triple integrals, but then, you know, the other case where some of the limits are, for a lack of better term, weird, not nice. So here, I have to make my judgment. Alright, let me just write the three integral sign first. We are integrating a very simple function, just 1, okay? However, the problem here is that am I going to put dx, dy, dz, or dz, dy, dx, or the other way around? There are 6 possible combinations, so which one of it? The idea is that, again, you have to make your own judgment. I see that from the question, if I integrate z first, if I do that, and then I substitute my z to be 0 and y. So can you see all the z disappears? The only thing that remains is 0 and y. So then I can imagine in my function here, initially it was x, y, z, just imagining. But once you already put in 0 and y, I only have x and y remaining. So next, if I integrate with respect to y and then put the limits to be 0 and x, even the y disappears. The only thing that left is x. So finally, I integrate with respect to x, put in 0 and 1, even the x disappears. So that's how I make my initial judgment. I see that the correct way to proceed this would be simply integrate with respect to z first, and then y, and then x. Doing any other way would not give me a number as the final value, I assume, because the limits are kind of weird here. So once you have settled down which combination you want to choose, everything else is exactly the same like the example you just did. But since just now you guys did the question, this time around let me do it. So z, the limit, what's the limits for z here? 0 to y. Okay, you have 0 until y. As for the y, you have from 0 until 1 minus x squared. For the x, I'm having 0 until 1. So with that said, again, all the outer integral remains 0, 1 minus x squared, 0, 1. But the inner integral, I'm going to solve it. If you integrate 1, you get z, right? That's it. You just get z. So the limit is from 0 until y. And let me just write dy and dx here. It's a very simple integral. So now I put in my y and then I put in my 0, I minus it. What becomes is integral of this, and this simply become y, because when you put 0, it's just 0. Okay, so now integration of y is again not a big deal. You integrate y, you get, my goodness, what happened? Okay. So you integrate y, you would get y squared over 2, again a basic integral. And the limit is from 0 until 1 minus x squared. Again, be very careful when you're substituting, because 1 minus x squared is a bit tricky. There's a power 2 here, so you don't want to miscompute it. So, alright, anyways, so let me just keep 0 and 1. And I put 1 minus x squared into the y, it becomes 1 minus x squared, the whole thing square over 2. Okay, so if you want to immediately integrate this, I don't think it's that easy because you have a power and then a power outside it. So the most logical way is to just expand it. And I would like to bring the denominator outside because I don't like to see a power 2 there. But if you want to keep it, then you keep it. Anyways, if I expand this, then it would become 1 minus 2x squared plus, isn't it negative y? Is it a negative y? Which part is it? Isn't it a negative y? Am I missing something here? Alright, if you guys sense that I'm doing something wrong here, oh, when you sub in 0 and y, I see. No, because when you substitute, you put in the upper limit first, then only the lower limit. So you put in y, it becomes y, minus 0, it becomes y. Okay, always substitute the upper limit first. So that's why it's not a negative y. Am I right? Yes, I'm right. Upper limit first. Anyway, so coming back to this, it would become x to the power of 4. Yep, and a dx here. Alright, so integrating this and then substituting 1 to 0, again, I'm just going to skip the steps because it's just a single integral. I did get 4 over 15. Okay, so this is not the thing that I wanted to emphasize now. The thing that I wanted to emphasize is that when you're choosing the combination of z, y, and x, make some initial judgment. Try to play around the scenario in your head. Which variable, if you choose first, and then the second, and then the third, will give you a nice number as the final answer. Okay, so that's that. And yeah, so that's it for the thing I wanted to cover today for the 1 hour class, because we have another class again at 4 to 5:30, isn't it? Here's the deal. Now it's 3:45. We continue back at 4 o'clock. But let me tell you, the thing that I wanted to cover at 4 o'clock is not much anyway. So I don't think it will go until 5:30. Chances are until 4:30 at most. But right now, let's stop here. I'm going to stop the recording. I'm going to share the whiteboard that I just scribbled it in the group so you can have a look at it. So you're free to go. 4 o'clock, we gather back here. Meanwhile, if you have any question, feel free to just ask in the group or in the chat. Alright, so I'll stop sharing the screen now. Meet you guys back at 4.
Sir, attendance?
Attendance, I will be taking it at 4 because it's the same group again, right? At the starting of 4, I will take the attendance. Or are you guys in different group? It's the same group, right? I saw in the timetable it's the same thing. So I'm assuming it's the same group, alright? So okay, see you guys later then.
Thank you, sir.
Okay.